Okay, so this video is going to be on chapter 2.1 of the OpenStax textbook on a general strategy for solving linear equations. Before we get into that, though, I'm just going to go over a couple of terms that we need to know. So the first one is the idea of a solution. A solution to an equation is a value of a variable that makes a true statement when substituted into the equation. And what that means is if we have this equation 5y plus 3 is equal to 10y minus 4, you might notice that only certain, really only one value of y is actually going to make that true. If we have something, if we say y equals 3, we can't just choose any number of y and make it true, right? If we choose y is equal to 3, 5 times 3 is 15, 15 plus 3 is 18, and then 10 times 3 is 30, 30 minus 4 is 26, 18 is not equal to 26, so that means that is not true. And so y equals 3 is not a valid solution to that equation. So that what a solution to equation just means that it makes it true, right? And so if we had an equation like 2x is equal to 4, the only thing that would make that true is if x equals 2, right? And then if x equals 2, then we have 2 times 2 is equal to 4, which is correct, right? Because that gives us 4 equals 4. So that's what a solution is. It's where you put the value in and then it makes the thing true. The other thing we need to know is, what is a linear equation? It's all a linear equation is it's any equation that can be written like this: ax plus b. Let me circle this. Ax plus b is equal to 0. A and b are just numbers, and then x is just a variable. So it could be an x, a y, a z, w, whatever letter you want to use. I will say it's not always obvious that it is a linear equation by this definition, because if we take an equation like this doesn't look like ax plus b equals 0, but it turns out it actually is. You just have to rearrange things a little bit. It's actually the same thing as negative 5y plus 7 is equal to 0. It's the same thing, but sometimes you'll just have to rearrange things a little bit, and we'll figure out how to do that in a second. So before we solve the equations, I just want to introduce this principle of how we can work with equations. So I like to use the illustration of a scale. You have a weight on each side, right? And you want to make sure it's always balanced, right? Because that means you have an equal weight on both sides. So if we want the scale to always be balanced, they have to have the same thing, the same amount of weight. So let's say I have a 2 on this side of the equation, right? And 2 on this side. Those are equal. Now, let's say we want to change something, right? Because a lot of the times with these equations, we're going to be needing to manipulate both sides to kind of get things where we want them. So we're going to have to change them. So let's say for whatever reason, I wanted to add a 3 over here. Well, now they are not equal, right? Because that scale is going to tip because it has more weight on the left side. So how do we correct that? Well, if I added a 3 on the left side, to correct that, I'm going to have to add a 3 on the right side also to balance that back out. So this is just illustrating the principle that we're going to see in equations, where anything that we do that changes the value on the left side or the right side, we're going to also have to do on the other side. And we'll see how that comes into play plenty of times throughout this video. So now I'll move on, general strategy. What's our general strategy? Every time we come to a linear equation, what is our sort of process that we do? And I'm going to go through these steps, but I'm going to go through it with an equation so you can see how it kind of plays out. So we're going to have this equation: 2/3 times 3m minus 6 is equal to 5 minus m. Okay, so step 1, it says to simplify both sides of the equation. So the 5 minus m, the right side of the equation, is pretty much already simplified. We don't really have anything we can do with that. But the left side, we've got a bit we can do. We can take this and distribute that 2/3 to each of these terms, right? And again, we're going to be using all of those things we learned in chapter 1, distributive property, adding and subtracting fractions, things like that. We're going to use those all the time in algebra and in solving linear equations. So just know that it was not in vain. Okay, so 2/3 times 3m, and I'm still simplifying here. I'm still in step 1. Minus 2/3 times 6 is going to equal 5 minus m. The 3 and the 3 are going to make a 1, right? 3 divided by 3 is 1, and 6 divided by 3 is 2. So 2 times 1 times m, or just 2m, minus, and then we have 2 times 2 is just 4, and that's still equal to 5 minus m. So now we have simplified both sides, right? So now what are we going to do? Well, step 2, it says collect the variable terms on one side of the equation, right? So right now we have one over here on the left side and one over here on the right side. These are our variable terms. We want to have them only on one side. I'm going to move everything to the left side. And the way I'm going to do that is basically we just need to get rid of this m over here on the right side. And so to do that, I'm going to add the additive inverse, right? So that's, again, one of those things we were learning in chapter 1. If I'm subtracting m here, then to get rid of it, I just have to add it, right? Minus m plus m, that's just equal to 0, right? But since that is changing the value of the expression, we also have to do it on the left, right? So I'm going to do it over here, plus m. Now, this reminds me, I do want to address, you might notice I didn't change anything, when I was doing this stuff up here, I only did it on one side, right? I was only multiplying by things on one side. I never did anything on the right side. And the reason is because I wasn't actually adding anything to that side or multiplying or anything like that. All I was doing was taking what was already there and rearranging it a little bit. Basically, I didn't do anything that changed the value of that expression. But when I do this over here, that is actually changing the value, right? Because we added an m out of nowhere. So that changes the value, so we have to do it on the other side as well. So that's why I'm doing it here. And so you'll see these m's will cancel each other out and make 0. And then these guys, 2m plus m, that's going to make a 3m minus 4 is equal to 5. And so we've basically moved all the variable terms to one side. And you can think of it like, I got rid of it on one side and then just kind of compensated for it on the other side. But for me, I like to think of it more like I took it from over here and I moved it to the other side. And whenever I move a negative m from this side to that side, it's going to become positive, right? If I take a positive m and I move it to the other side, it's going to become negative. It's the same process, it's just a different way of thinking about it. I don't know if it'll help you, or if it doesn't help you, just do it the other way. Okay, step 3 says to collect the constants on the other side, right? We have one on the left, one on the right, and we want to get rid of the one on the left, right? We want all the constants to be on the opposite side of the variable. So we're going to get rid of the 4 on the left and put it with the 5 on the right. And how are we going to do that? Same exact way we did it with the variables. To get rid of a minus 4, we're going to add 4. But since that's changing the value, we've got to do it on the other side also. So 5 plus 4 over here. And so now we can just kind of evaluate. This is going to cancel itself out. And so we're going to get 3m is equal to 5 plus 4, which is 9. Okay, we're getting really close here. So that was step 3 up here. Step 4 says to make the variable coefficient equal to 1. So that means this guy right here. That's the variable coefficient. And we want to make that equal to 1. And so to do that, this is a multiplication, so we're going to have to divide by 3 to make that a 1. And if we're dividing by 3 on the left side, we also have to do it on the right side. And so now, now this 3 and 3 is going to make a 1, which is just going to be m. And then 9 divided by 3 is just 3. So that would be our answer, m equals 3. But you'll notice there's another step. Step 5, check solution. And this is an important step because it, a lot of the times in math you're like, oh, did I get the right answer or not? I don't know. Well, it turns out with equations, you don't have to be confused about that. You actually can figure that out. And the way we do that is we just take this equation that we had at the top, which was 2/3 times 3m minus 6 is equal to 5 minus m. You can just take that and replace m with 3. So let's just put 3. And 3 by 3, that just means whatever answer you got. You take it and put it back into the original equation. So if I take that, okay, that's a 3, and it's a 3. Now we see if it turns out to be something that's equal, right? So 2/3 times 3 is going to be, these are going to cancel. So 2 times 3 is just going to be 6. And then the 2/3 minus, we're subtracting 2/3 times 6. The 6 and the 3 make a 2, right? So that's going to be a 4. So 6 minus 4 is going to equal 5 minus 3 is just 2. 6 minus 4 is also 2. So 2 equals 2. And that is correct. So that means we did get the right answer. So that's actually, a really nice thing about equations is you can actually find out for yourself if you got the right answer. You don't have to leave it up to chance. Okay, let's do some more examples. This one is a little bit, it's kind of the same thing, but it's good to practice it more. So we're going to have the equation 4 times x minus 1 minus 2 is equal to 5 times 2x plus 3 plus 6. Okay, so the first thing we do, that has a parentheses. The first thing we're going to do, step 1, simplify both sides. So the left side, 4 times x, right? I'm just distributing like I always do. 4x, that's going to be 4 times 1 is 4. Then we have the minus 2. 5 times 2x is 10x, plus 5 times 3 is 15, and then we have that plus 6. Now we'll combine like terms, so we'll say 4x minus 4 minus 2 is going to make a minus 6. Sorry, that's bad x. It's going to equal 10x plus 15 plus 6 is going to be a plus 21. And now, okay, so step 2, step 1, simplify. Step 2, move all the variables to one side. I'm going to move this 4x over by the 10x, and I'm going to do that by subtracting it here, right? 4x minus 4x is 0. 10x minus 4x, that'll be 6x. So now we'll say, okay, that's gone. So now we're going to have a negative 6, right? The negative stays there. 10x minus 4x is just 6x, and then we have a plus 21. And then step 3 is we're going to move that constant over to the other side, that 21. And so we're going to do that by subtracting 21 minus 21 is 0, and then minus 6 minus 21 is going to be minus 27. And then over here, we're just going to have our 6x still. Step 4, make the variable coefficient equal to 1. And so we do that by dividing by 6 on both sides. And so we're going to get negative 27 over 6 is equal to x. And I'm going to take it just a little bit farther because we can actually simplify that fraction. So this is actually the same as negative 3 times 3 times 3 divided by 3 times 2. 2 of those 3's will cancel, and so now we'll get negative 9 halves. So in other words, our final answer is x equals negative 9 halves. So then we're just going to do step 5, which is to check it, right? So if we get our yellow for checking here, 4 times x minus 1 minus 2 is equal to 5 times 2x plus 3 plus 6. What we're going to do is we're going to take our negative 9/2 that we got down here. Don't forget the negative. And we're going to plug it into this equation up here. So we're going to say 4 times negative 9/2 minus 1 minus 2 is equal to 5 times 2 times negative 9/2 plus 3 plus 6. Now we'll kind of simplify these. So distributing, 4 times negative 9/2, the 2 is gonna, 4 divided by 2 is 2. So that'll be negative 18 minus 4 times 1 is 4. Sorry, wait, minus 4. And then minus 2. And then we'll have, that's equal to, this 2 times negative 9/2 is going to cancel with that 2 over there. So we're just going to have negative 9 times 5, which is 45. And then the 5 and the 3 over there is just plus 15. And then our plus 6. And so now we'll simplify this further. Minus 18 minus 4 is minus 22. Minus 22 minus 2 is going to be minus 24. And then minus 45 plus 15, that's going to be minus 30. And minus 30 plus 6 is going to be minus 24 again. And so you see these are equal. So that checks out. So we know that our negative 9/2 here, that was the correct answer, right? Because we plugged it in and it gave us a true statement. That's the definition of a solution. So negative 9/2 was correct. Okay. So the last couple of things I just want to go over real quick are when we have fractions and decimals. So let's get this new equation here. Okay, so in this equation we have fractions. And they're being added and stuff, and so everything's a fraction. What are we going to do? Well, the first step, kind of towards simplifying these problems, get rid of the fractions, right? We don't like fractions. Fractions make things difficult. And so what's the easiest way to do that? Well, the easiest way to do that is actually to find the LCD and multiply both sides of the equation by the LCD. And when I say the LCD, I mean the LCD of all the fractions that are in the equation. You're just going to find the LCD of all of them all at once. So we're going to take all the denominators we have, 12, 6, and 4, and we're going to take the prime factorization. So 12 is 2 times 2 times 3, 6 is 2 times 3, and 4 is 2 times 2. And I know I'm kind of going through these kind of fast, but we went through it slower in some of those other chapter 1 videos, and you can do it as long as it takes you. It doesn't matter. I'm just going fast because I want to get done with the video faster. So if we do this, now we build our LCD, right? So how many 2's do we need minimum? Well, we need 2. So 2 times 2. And then how many 3's do we need? Just 1. So our LCD is going to be 2 times 2 times 3, which happens to be 12, which we already had up here. That happens sometimes. That's very normal. So what we're going to do is we're going to take that 12 and we're going to multiply both sides of our equation by that. So what we're going to do is we're going to take this, multiply that by 12, and also take that and multiply by 12. And so now what we're going to get is this 12 is going to cancel with that 12 and just make 1. And it's also going to cancel with that 6 and it's going to make a 2, right? So 2 times. Actually, I should do that more in a way that you can see better. So 12 times 1/12 x plus 12 times 5/6 is going to equal 3/4 times 12. And now we'll see this 12 and 12 cancel to make a 1. This 12 and this 6 make a 2. 12 divided by 6 is 2. And 12 divided by 4 is 3 up here. So what we're going to get is just 1x plus, oops, my bad. Let's get back to where we were. Okay, so we're going to have 1x plus 2 times 5 is 10. And then that's going to equal 3 times 3, which is 9. And so now this has become a much simpler equation to solve. In fact, it's really easy at this point. All we have to do is say we only have the variables on one side of the equation already. So that step 2 is already taken care of. Step 3, move all the constants to the opposite side. So we're going to subtract 10 on both sides. Let's bring up my little thing here. Minus 10, minus 10. And so we're going to get x is equal to 9 minus 10 is just going to be minus 1. So that will be our answer, and then we would check that the same way we would check any other equation. And I'm just going to, we'll do everything. So we'll check this equation. So we had 1/12 times -1 plus 5/6, and we want that to equal 3/4. So you can kind of see that -1 is just going to become a negative sign out here. So really the first thing we're going to want to do is we're going to add these two fractions, well, really add all the fractions, make them equal to one type of fraction. We're going to use the LCD for that. And so we already calculated the LCD, which was 12. You'll remember that when we're adding fractions, we're not going to multiply by the LCD. We're actually going to multiply by the LCD over itself, right? So that's basically going to be the same as saying 12 over 12, right? 12 over 12 times -1/12. Actually, sorry, that's wrong. We're going to multiply by what we need to get that fraction's denominator to equal 12. So in this case, it's already there, so we can just write that one down, -1/12. For this one, what does it take for 6 to get to 12? Well, it needs an extra 2, right? So we're going to multiply by 2 over 2, which is the same as 1, times 5/6. And then over here, 3/4, what does it take for 4 to get to 12? It needs an extra 3, right? So we're going to multiply by 3 over 3 times 3/4. And so now we can kind of consolidate this all into a bunch of fractions over 12. So this will be 2 times 5 is 10 over 12. And then is going to equal 3 times 3 is 9, again, over 12. And you'll see -1/12 plus 10/12 is equal to 9/12, and that is equal to 9/12. So this is the correct answer. That's not the correct answer. The correct answer was -1 up here that we got up here. And we verified that like this. So now, let me put that check mark back. I'm just going to do one really quick that is with decimals. And the trick with decimals is we're going to want basically to just to turn them into a fraction. That's the gist of it. So if we have 0.25x plus 0.05 times x plus 3 is equal to 2.85. Right? That's kind of intimidating. We've got lots of decimals. Let me write that better. You got lots of decimals and stuff. It overall looks pretty intimidating. The trick with this, you just turn these fractions, these decimals into fractions. So the 0.25x, right, that's what that is that's 25 out of 100, right? And we covered converting decimals to fractions in 1.4, I think. So that's just going to be 25 over 100 times x plus 0.05, that's 5 out of 100. And then that's times x plus 3. And then that's going to be equal to 2.85 is the same as 285 out of 100. And now you'll see it's the exact same thing as working with fractions. Super simple to work with this. And it turns out they actually all have the same denominator in this case. So we don't even have to do our LCD thing. We'll just kind of get straight to simplifying. So we'll have 25 over 100 times x plus 5 over 100 times x is just 5 over 100x. And then plus 15, right? 5 times 3 over 100 is going to equal 285 over 100. And now we make sure we move all the x to one side and all the constants to the other side. These ones will just combine, so 25 over 100 plus 5 over 100 is 30 over 100x. And then this 15 over 100, right, we're going to minus 15 over 100 so that we can bring it to this side, which is also going to subtract 15 over 100. And so now we'll have 30 over 100x is going to equal, and these guys are going to cancel. And then we'll have 285 over 100 minus 15 over 100. That's the same as 285 minus 15, which is 270, I believe. At this point, and you could have done this earlier, but I think the best course of action here is to just multiply by 100 on both sides, just to clear out those denominators, right? So that'll cancel them out, and so now we'll have 30x is equal to 270. Okay, now we do step 4, which is to make the variable coefficient equal to 1. And we do that by dividing both sides by 30. And we'll get those cancels, so we get x is equal to 270 over 30. And just to simplify that fraction, we can take out those zeros, first of all, because that's just dividing by 10, right? And then now we can factor 27 over 3. That's the same as 3 times 3 times 3 over 3. And those cancel, so we just get a 9. So x equals 9 is our answer to that. And you could verify that. I think I'm just going to let you do that as kind of a homework assignment. That's step 5, check your answer, right? All you would do is you'd take that x equals 9 and you'd plug it back into that original equation we had up here. That guy. You just put it in there and see if it comes out to be a true statement. And if it does, then that x equals 9 is the correct solution. So I hope that video is helpful. You're going to be doing this a lot in algebra, so get comfortable with it. Do the practice problems in the textbook if you need to. And I'll see you in the next video where we're going to talk about more of this stuff.